So let's explore the cartilages. Now, cartilages have qualities that are somewhere between dense connective tissue and bone. So that is, cartilage are tough, but they are flexible as well. So they are generally found in places where either dense connective tissue or bone by itself would not be an acceptable tissue to have. So the cartilages as a whole are avascular, which means that they have no blood vessels or internal blood supply within them. So this gives them a very slow metabolism, which means that they are slow to grow and repair any damage as well. So they are slow to heal if the cartilages are damaged in any way. Their extracellular matrix contains a high amount of a substance called chondroitin sulfate and hyaluronic acid. And both of these substances really serve to trap a lot of water within the cartilage extracellular matrix. Cartilages are actually about 80% water or so. And so this is really what gives them kind of their toughness, is just the fact that they're full of water. The collagen and elastic fibers that are within them give different properties to the cartilages. So some cartilages have only collagen fibers, some have only elastic fibers, and the type of fiber that they have gives that cartilage different properties, and so we'll see that reflected in the cartilage structure as well. Because of all of these properties together, cartilage is a good tissue that resists both tension and compression. And so some cartilages are found in places that are subjected to mostly compression, some places that are subjected to mostly tension, or some combination of both. And again, we'll see that in the cartilage types and where they're located as well. So let's take a look at the three cartilage types here. So we have hyaline cartilage, elastic cartilage, and fibrocartilage. So let's go through them in that order and take a look at each one individually. So starting with hyaline cartilage, we see that hyaline cartilage is found in quite a diverse number of locations within the body. I should say too that cartilage as a whole, not just hyaline cartilage, but all of the cartilages together, are generally found associated with the skeleton. Hyland cartilage specifically covers the ends of long bones, so it forms kind of the protective caps that are at the end of two bones that come together in a synovial joint. It's found making up the cartilage that makes up kind of the bulk of the anterior part of the nose. It is found in little beams or bars of cartilage that connect our ribs to our sternum in the thoracic cage. Hyaline cartilage forms these like C-shaped rings that give support to the trachea, which is part of the respiratory system. And we see that hyaline cartilage actually forms most of the embryonic skeleton. So during development, most of your skeleton is not actually bone. Most of it is actually hyaline cartilage. And so later on during development, and even after we are born, that hyaline cartilage is slowly replaced by bone tissue. And so the majority of our skeleton begins as hyaline cartilage. Right? So looking specifically at hyaline cartilage and what its cells and extracellular matrix are made out of, the primary fiber type that we see within the extracellular matrix are collagen fibers. And those collagen fibers exist in a glass-like looking extracellular matrix here. And so everything that you're seeing here kind of stained in the pinkish, reddish color here is the extracellular matrix. The individual collagen fibers are not really easy to see, so they all kind of look like it's this kind of evenly mixed jumbled mass here. And so the primary fiber type that we see are collagen within the extracellular matrix here. The cells that are embedded within the cartilage extracellular matrix are referred to as chondrocytes. So there's that suffix there, cyte, which just means cell. Chondro refers to cartilage here, so cartilage cells are usually referred to as chondrocytes. And these chondrocytes reside in tiny little cavities within the tough extracellular matrix. Those tiny little cavities are referred to as lacuna, and so that's just a little space for the cell to actually take up some space within that extracellular matrix there. In Hyland cartilage, you see that the chondrocytes or cartilage cells are usually arranged in pairs or groups of 3, are not particularly uncommon in Hyland cartilage. So that's a really easy way to tell Hyland cartilage apart from the other cartilages, is that the chondrocytes tend to be arranged in pairs or groups of 3. Hyland cartilage is one of the most abundant cartilages in the body. It has essentially a bone-like strength, but it's more flexible than bone, so that's why we tend to find it at places where bone by itself would not be an acceptable material to use, simply because it has more flexibility than bone does. It's a great cartilage at resisting mostly compression, so that makes it fairly similar to bone, because bone is also really great at resisting compression as well. Bone is not a particularly good material in tension, and neither is Hyland cartilage. So let's move on to elastic cartilage. It has a more limited set of locations within the body. Elastic cartilage supports the external ear and a structure called the epiglottis. Now, we're all familiar with the external ear, so what you're seeing there is underneath the skin anyway, and is elastic cartilage. So the bulk of the material that makes up the external ear is elastic cartilage, and that's what gives the external ear the ability to spring back after you deform it. So elastic cartilage is really great at holding its shape even when deformed, and then when you remove whatever force or pressure you're applying to it, it springs back to its original shape. And so we're familiar with the external ear. Another structure that we may not be as familiar with is a structure called the epiglottis. And so what you're looking at here is this is actually the larynx right here, or the voice box. And so the larynx is a cartilaginous structure that's within the throat, and the larynx itself is not made out of it's not made out of elastic cartilage. It's actually made out of hyaline cartilage. But the epiglottis, which sits above the larynx in the throat, is made out of elastic cartilage. And the epiglottis is a structure that essentially closes off the trachea here when we swallow, so that food is directed into the esophagus, which is behind the trachea. We can't see the esophagus here, but it would be directly behind the trachea. And so that way when we swallow, food is directed into the esophagus and not into the trachea. Because we need food to, of course, go into the digestive system. Food doesn't do very well when we put it into the respiratory system. So there we have it for elastic cartilage. So we see it in the external ear and the epiglottis. As far as the visual appearance of elastic cartilage goes, we see that the chondrocytes really don't have a specific arrangement. They're arranged more kind of randomly within the extracellular matrix there. What we can see in the elastic cartilage, as we see very visibly, very dark staining here, are the elastic fibers in kind of a purplish black color here. And so what you're seeing between the cells of the chondrocytes are the elastic fibers there. So the major attributes of elastic cartilage are that elastic cartilage has both great strength and flexibility. So it's really good at resisting things like tension. As we've seen with the external ear and epiglottis structures, it serves as a soft supporting structure for those two. And if we deform it, that is, if we try to change its shape, it will simply spring back to its original shape once we've removed that force that we've applied to it. Last but not least, here we have fibrocartilage. And fibrocartilage has a few locations within the body, not quite as well distributed as we see with Hyland cartilage, but it is in some very important locations in the body and does serve a very important function there. So the three major locations that we'll highlight here are the intervertebral discs, the pubic symphysis, as well as the discs within the knee joint here. So to show you where each of those is at, the pubic symphysis is actually it's a little pad of fibrocartilage that exists between the two pelvic bones here. And so we see that those two bones are joined anteriorly by the pubic symphysis. It also makes up the majority of the discs that sit between each of our vertebrae here, give our vertebral column kind of a springiness to it. And we also see that it makes up these pads called the menisci within the knee joint here. So the lateral and the medial meniscus within the knee joint are made out of fibrocartilage, and that helps to support the, this would be the femur here, and this would be the tibia. So it helps to support the femur on top of the tibia, as well as keep those two bones aligned during any normal knee joint movement. Fibrocartilage, its appearance under the microscope, we see that the main fiber type, or the primary fiber type in the extracellular matrix, is collagen. These collagen fibers are much more visible than they are in hyaline cartilage, and we see that they're arranged in essentially like flat kind of sheets here. And between the sheets, we see rows of chondrocytes, and these chondrocytes are generally in rows of about 4 to 5 cells or so. So we saw the fibrocartilage's locations in the pubic symphysis, the intervertebral discs, and in the pads of the knee joint there. The places that fibrocartilage is found tend to experience both tension and compression, and so and because of that, fibrocartilage is really good tissue that resists both tension and compression really well. So it's kind of an intermediate between hyaline cartilage and elastic cartilage, in that it's able to resist both of those types of forces.